I am Anil Kumar. Welcome to my series on solved previous test papers. Let me thank all the students and subscribers for sending their test papers. It's a privilege to solve these question papers and present them to all the students around the world. I hope you are really benefiting from these. Now here is a test paper on related rates, calculus, IB students. Let me congratulate the student whose test paper I have taken since he has almost 98% marks. Okay, here are the questions. So we'll have about 9 questions. You can pause the video, copy these questions. The very first one is, at what point is the tangent to the curve parallel to a given line, right? Second, find equation in standard form of the tangent to the curve at a given point. Third, the motion of a particle is described by a function which is cubic function. Where t is measured in seconds, you need to find when the particle is at rest, when is it moving along in the negative direction, when is the acceleration positive, is the particle moving towards or away the initial position, when the acceleration is 0, and you need to find the total distance traveled in 8 seconds. Question number 4 here is, the edge of a cube is expanding at a rate of 3 centimeters per second. At what rate is the volume changing when the edge is 10 centimeters? Then we have some application questions. Question number 5. An outdoor light is at top of a 5-meter gate. Paul is 2 meters tall and walks away from the gate on a straight path with a speed of 1.5 meters per second. How fast is the shadow changing when Paul is 10 meters from the gate? Question number 6. Oil spilled from a reputed tanker in a circle whose area increases at the rate of 6 kilometers square per hour. How fast is the radius of the spill increasing when the area is 9 pi kilometers square? Question number 7. A spherical balloon with radius 10 meters leaks and is losing air at 150 meter cube per minute. Find the rate of decrease of the radius after 6 minutes. Question number 8 and 9. Question number 8. Sand is being poured onto a conical pile at the rate of 9 meter cube per hour. Friction forces in the sand are such that the slope of the sides of the conical pile is always 2/3. How fast is the altitude increasing when the radius of the base of the pile is 6 meters? The last question here is question number 9. At 4:30 p.m., a car traveling east at 100 kilometers per hour is 45 kilometers west of an intersection, while a truck traveling north at 60 kilometers per hour passes through the same intersection. At what rate is the distance between the two cars changing at 4:45 p.m.? Are they separating or approaching each other at this time? So that's the 9 questions for you. I hope you find them interesting and useful. You should first try attempting them and then look into my solutions. Take this as a review on related rates. Question number 1. Let's solve them one by one. Okay. So the very first question here is, at what point is the tangent to this curve parallel to the line x plus 2y equals to 0? So what is the slope of x plus 2y equals to 0? We can isolate y, so we get minus x, and y equals to minus half of x. So the slope of this line is minus half. Okay, so basically we need to find a point on the curve where slope of the tangent line is minus half, correct? So that is what we need. So let's find the derivative. So the function given to us is x plus y square equals to 1. Let's differentiate with respect to x on both the sides. So we get 1 plus 2y dy dx, implicit derivation, right, is equal to 0. So taking 1 on this side, we get 2y dy dx equal to minus 1, or derivative with respect to x is minus 1 over 2y. So that becomes the derivative. Now we need this slope to be same as minus half, correct? So we can equate these two. Perfect. This has to be same since we are talking about parallel to the line, correct? So these two things are perfectly matching. So we could write this as minus half is equal to minus 1 over 2y, correct? That means what? That means y is equal to 1. Now if y is 1, we can place 1 here and find what x is. So we get x plus 1 equals to 1, that means x equals to 0. So the coordinates of the point are 0 and 1, right? So the coordinates are 0 and 1. Does it make sense to you? So the question was, at what point is the tangent to this curve parallel to the line? So the answer is at the point 0, 1, correct? So that is how you should be solving it. Question number 2. Find the equation in standard form of the tangent to the curve 2 times x square plus y square whole square equals to 25 times x square minus y square at the point minus 3, 1. So let's write down the equation and find its derivative with respect to x. We have x square plus y square whole square equals to 25 times x square minus y square. So what we are going to do here is we'll differentiate with respect to x on both the sides, correct? So this 2 times 2 becomes 4, let me write here 4, times x square plus y square times the derivative of inside function, which is 2x plus 2y dy dx, correct? Here we get 25 and the derivative will be 2x minus 2y dy dx. So that is how we are going to do the derivative. So we combine the chain rule. Now we are given that the point here is minus 3, 1. We need to find dy dx. So I'm going to substitute x equals to minus 3 and y equals to 1. So what you get here is 4 times minus 3 square, which is 9, plus 1 times minus 3 times x, right? So minus 6 plus 2 times dy dx. So I'm straight away multiplying, substituting x as minus 3 and y as 1, correct? 25 times minus 6, and this gives me minus 2 dy dx, correct? So that is 40. So we get 40, and here we have minus 6 plus 2 dy dx equals to 25 minus 6 plus twice dy dx. So let's open the bracket and then simplify it further. So minus 6 times 40 is minus 240. Then we have plus 80 dy dx equals to minus 150, and this is plus 50 dy dx. Bringing dy dx together, we get 80 dy dx minus 50 dy dx equals to minus 150 plus 240, correct? So that gives you 30 dy dx equals to, we can take away from 240, this, and so we get 0, and then we have this as 90, right? So 90. So we can now divide by I made a mistake here. This was minus, I'm sorry. So this is actually minus, so it becomes plus, and it is 130. Right? So 8 plus 5 is 13. So it is 130 dy dx equals to 90. So from here we get dy dx as equal to 90 over 130, or 9 over 13. Correct? So we get our slope at the given point. Now we need to write equation in standard form, which is y minus y1 equals to m times x minus x1. Correct? So we know here that the 2 points, the two values of x and y are minus 3 and 1, and the slope m is 9 over 13. Correct? So we're going to use this. So we have y minus 1 equals to 9 over 13 times x minus 3, which makes it plus 3, right? So we can now multiply by 13 and then write down the equation as 13y minus 13 equals to 9x plus 27. Bringing them together gives us 9x minus 13y plus 27 plus 13 equals to 0, or 9x minus 13y plus 2 plus 1, 3, and 1, 4. So 9x minus 13y plus 40 equals to 0. So that becomes the equation of the tangent line in standard form. Now this is tangent to the given curve at the given point, right? So I hope that makes sense. Let's move on to question number 3 now. Question number 3. The motion of a particle is described by the function s of t equals to t cubed minus 12t squared plus 45t plus 3, where t is greater than or equal to 0, where time t is measured in seconds and s in meters. Now it has 5 parts. You need to figure out when is the particle at rest, when is the object moving in the negative direction, when is the acceleration positive, is the particle moving towards or away from its initial position when the acceleration is 0, and is to find total distance traveled in the first 8 seconds. You can always pause the video, answer the question, and then look into my suggestions. Now this is displacement, velocity, acceleration application. Let's begin with the displacement function, which is s of t equals to t cubed minus 12t squared plus 45t plus 3. Derivative of this will give us the velocity, right? So velocity is equals to derivative of displacement, which will be 3t squared minus 24t plus 45. Now let's factor this. So we get 3 common, we get t squared minus 8t plus 15. Now 15, that means 5 times 3, so we could even factor this, t minus 5 times t minus 3. So that becomes the velocity function. Now part A, when is the particle at rest? So at rest, we know velocity is 0, right? So part A, v of t should be equal to 0 at rest. And that gives you 2 positions. If I equate this to 0, t equals to 3 and 5, right? T equals to 3 and t equals to 5. These are the 2 solutions. Perfect. Part B. When is the object moving in the negative direction? Now, negative direction, we have to figure out when is velocity negative, correct? So that is to say, what we could do is, we can analyze the zeros. Okay, so let's say we'll make a table and then figure it out. So let's say this is at t equals to 3, this is at 5. Let's take test points. Okay, so 0, 4, and 6 could be test points. And then we have our factors, which is t minus 5 times t minus 3 times 3. Let's say velocity, right? If I substitute 0 here for t, I get negative negative as positive, correct? If I substitute 4, in that case, this will be negative and this will be positive. And negative and positive will give me negative. And if I substitute 5, 6, in that case, both are going to be positive. This is one way of doing it. The other way is that you could sketch the graph, right? You know these two zeros. Leading coefficient is positive, so you are expecting a parabola which is going through both the zeros, kind of like this. So it is the interval between 3 and 5 when the velocity is negative. So when we say, when is the object moving in the negative direction? So it is from t equals to, let me write here, this is when t is greater than 3 and is less than 5. So this is the time when the particle or the object is moving in negative direction, or we can say v of t is less than 0, correct? So that is the part B answer. Okay, I hope this is absolutely clear, right? Now let's look into part C. When is the acceleration positive? So let's find the acceleration, which is derivative of the velocity, right? So we'll use this particular expression. The derivative of this velocity will be 2t minus 8, correct? Which I can factor 2 out. It becomes 6 here. And so we get t minus 4. So when is acceleration positive? This is a straight line, correct? So as you can see, the acceleration is kind of a straight line. And what you notice here, that the x-intercept, or it is 0 at 4, right? So it is 0 at 4. So it is positive after 4. So we see that acceleration t is greater than 0. That means t is greater than 4, correct? So when is acceleration positive? We can say when time is greater than 4, correct? So that is how you could answer this part. Part D is the particle moving towards or away from its initial position when the acceleration is 0? That means we need to analyze this point, 0. And at this point, whether it is moving towards or away from its initial position. So I'd like you to pause the video, answer this part and also part E, and then look into my suggestions. I'll take up these solutions in a fresh page. Okay? So now let us consider part D. Is the particle moving towards or away from its initial position when the acceleration is 0? So as far as part D is concerned, we found that acceleration equals to 0 at t equals to 4, correct? So for moving away and towards, the condition here is that the product of displacement and velocity, if it is greater than 0, then it is away, right? But if this product s of t, let me write here, if s of t and v of t is less than 0, then it is towards initial point. Is that clear? So we need to consider the position and the velocity, both of them at t equals to 4, correct? That is kind of very important. So we already have s of t. So let me write the value at 4. So which will be equals to 4 cubed minus 12 times 4 square plus 45 times 4 plus 3. So let's use calculator to calculate this value. So it is 4 cubed minus 12 times 4 square plus 45 times 4 plus 3. This is equal to 55. So this is positive 55. Now what was the velocity? Let's calculate velocity at 4. Well, let me write the expression for velocity first, which is 3. We remember, right, 3 times, in the factored form, we wrote t minus 5 times t minus 3, correct? This is simpler. So at 4, I could replace 4, and then it's easy to calculate 4 minus 3. This is negative and that is positive, so we get minus 3, which is negative. So as you can see here, the product of velocity at 4 and displacement at 4 is basically minus 3 times 55, and this is less than 0, and therefore we can say the object is moving towards initial point. Is that clear, right? So that is how you're going to answer this question. It's kind of very critical to understand, and I hope this particular knowledge helps you to answer similar questions. Now let's look into part E. Find the total distance. It is not displacement, total distance in first 8 seconds. So what we know here is that the object actually starts at 3, it moves and then it turns and then turns back. And these turning points are at t equals to 3 and 5. So at t equals to 3 it turns, and at t equals to 5 again it turns, and this position here is at t equals to 0, s is equals to 3, right? So if I substitute 0 here, we get s equals to 3. We should now find the displacement at 3 and 5 and also at 8, correct? So let's calculate. So we'll find what is the value of s at 3. So we'll substitute 3 here, which is 3 cubed minus 12 times 3 square plus 45 times 3 plus 3 equals 2, correct? So let's use the calculator. 3 cubed minus 12 times 3 square plus 45 times 3 plus 3 equals to 57, right? Now at s equals to 5, we'll just replace 3 with 5, correct? And recalculate. And that is equals to 53. Now at s equals to 8, what is the position? We'll again replace 5 with 8 now. So the displacement at 8, t equals to 8, is equal to, we're changing 5 to 8. So I hope you understand what I'm trying to do. The figure is there in the calculator, so I'm just changing 5 to 8. We get 107 here, okay? Well, there could be calculation errors, but you should do these calculations on your own, right? So t equals to 8, we get s equals to 107. Now, it is easy to find total distance traveled in 8 seconds, right? So distance in 8 seconds is equal to sum of all this, right? So we calculated from here to here is how much. So it is 57 minus 3, sorry. So we could write this as, this distance is here, s is equals to 57, correct? So 57 minus 3, so that gives you 54. And then here we had at t equals to 5, 53, so that means this is 4 units, and then 107 minus this. So this is basically equal to the value, right? So it is 57 minus 3 plus, then this is absolute values of 57 minus 53 plus 107 minus 53. Correct? These check the absolute values. That should be okay. So let's calculate this. So we have 57 minus 3 plus So I'll take away from the bigger value, right? We'll write this as 4 plus 107 minus 53. So that gives you 112 units. It is in meters. So the total distance covered is 112 meters. So whenever you're trying to find the distance, remember, you need to check turning points and add absolute distances. As we did here. Do you see that? So that is how you actually solve this question. I hope it helps. So question number 4. The edge of a cube is expanding at the rate of 3 centimeters per second. At what rate is the volume changing when the edge is 10 centimeters? So let's say this is our cube. Which is expanding, correct? So let's say the sides are S. Each side is equal, correct? Now, what we are given here is that the edge of the cube is expanding at the rate of 3 centimeter per second. That means it is ds dt, right? Time, with respect to time. At what rate is the volume changing when the edge is 10 centimeters? So we need to find the rate of change of volume when S is equal to 10 centimeters, right? So that is what it is. Now, we know that the volume of a cube is equal to S cube, right? So differentiating with respect to time, we get dv dt. So we are differentiating with respect to time, correct? Equals to 3s square ds dt. So at s equals to 10, we can just substitute the value. We know ds dt. So rate of change of volume with time at s equals to 10 should be 3 times 10 square, and ds dt is 3, right? So it is 3. So we get this as 9 and 100. And the units are centimeters per second, correct? So that is how you could easily solve this question. I hope it is straightforward. Now let's move on to question number 5. An outdoor light is at the top of a 5-meter gate. So let's say this is the gate and here we have the light. Paul is 2 meters tall and walks away from the gate on a straight path. So let's say this is the straight path on which Paul is walking with a speed of 1.5 meters per second. How fast is the shadow changing when Paul is 10 meters from the gate? Okay, so shadow. So let's say, let me sketch this diagram. Okay, now let us assume that, so let's say this is the position of Paul, right? So what we are given here is that an outdoor light is at the top of 5-meter gate. So this height is 5 meters. Paul is 2 meters tall. So this is 2. And walks away from the gate. So let's say is x distance away. So he's walking away from here. So this rate is dx dt. At the rate of 1.5 meters per second. How fast is the shadow changing when Paul is 10 meters from the gate? Now shadow. Now you should understand this part. The shadow is this length. So this is the shadow. So let's say this point is x, right? So that is the value. So let's call the shadow length as s itself, right? Okay, so from here to here it is s. Perfect. So that is the situation. So that means the total length here is x plus s from this place to this place. Correct? Now such questions wherever you have light and shadow we'll do with similar triangles. So the big triangle is similar to the smaller triangle, And therefore, we can write down that the height ratio 5 over 2 should be equal to the distance x plus s over s. So that gives us the relation. You get an idea, right? So now we can actually cross multiply. So we get 5s equals to 2 times x plus s, which is 5s equals to 2x plus 2s, right? So bringing it together, we can write this as 5s minus 2s equals to 2x, which is 3s equals to 2x. Now we can find derivative both sides with respect to time. So let's differentiate with respect to time. So when you do that, you get 3 ds dt equals to 2 dx dt. Correct. What we are given? We are given dx dt. Perfect. So since we are given dx dt, we can easily find what is rate of change of shadow length. So ds dt will be equal to 2/3 of dx, this is dt, dx dt, right? So which is 2/3 of 1.5, correct? So that is 3 over 3, which is 1. So we get as 1 meters per second is the rate of change of shadow length with respect to time. Now since this is constant, it really doesn't matter whether it's 10 meters away or whatever, right? So we can say that ds dt when x equals to 10 is also equal to 1 meters per second, correct? So that becomes the solution in the given case. Perfect. So that is how it should be solved. I hope the steps are absolutely clear. Now let's move on and take the next application. Question number 6. Oil spilled from a reputed tanker in a circle whose area increases at a constant rate of 6 kilometers per hour. So dA over dt is 6 kilometers square over hours. So hours is in time, so area over time. How fast is the radius of the spill increasing? So we need to find dr dt when area is equal to 9 pi. Right, so that is the question for us. Now we need to know also what is the radius when the area is 9 pi, correct? So that is another thing which we should be knowing. Okay, so area is given as pi r square. So we know area is pi r square, and if area is 9 pi, in that case r square is 9, right? So we'll just cancel these. So we know that 9 is r square, so 3 is r. So that means basically what is the rate of change of radius when the radius is equal to 3? Does it make sense to you? So we just calculated the value of radius when the area is 9 pi, correct? So that is actually very important to work out. Now, how fast is the radius of the spill changing? So we know area is equal to pi r square. Differentiate with respect to time, so we get dA dt equals to 2 pi r, right? 2 pi r dr dt. Okay, so we want to find what dr dt is, which is 1 over 2 pi r times dA dt. That is dr dt, correct? Since we know that r equals to 3 at area of 9 pi, so we basically want to, we know area is 9 pi, at that time radius is 3. So we need to find what is dr dt when area equals to 9 pi or r equals to 3. So let's substitute. So we get 1 over 2 pi times 3, and dA dt is 6, correct? So 3 times 2 is 6, they cancel, so we get dr dt as 1 over. So let me just cancel this. 6, 3 times 2. So we get 1 over pi equals to dr dt at area equals to 9 pi. Correct? So that is how we are going to find the answer, right? So that is our answer, which is rate of change of radius dr dt is equal to 1 over pi. Now radius is in kilometers, right? And time is in hours. So it is kilometers per hour. Perfect. So that is how you're going to solve it. Let's move on and take up the next application question. Question number 7. A spherical balloon with radius 10 meters leak and is losing air at 150 meter cube per minute. Find the rate of decrease of the radius after 6 minutes. So what we are given here is 150 meter cube per minute. So that is the change in volume, right? So spherical balloon with radius of 10 meters leak and is losing air. So that is dV dt. Time is in minutes, right? And since it is losing, so we'll do minus 150 meter cube per minute. Perfect. Find the rate of decrease. Now since already we are saying decrease, we'll get minus answer, right? So, okay. Find the rate of decrease of the radius after 6 minutes. So we need to find dr dt when time equals to 6 minutes. Right? So that is what we need to do. Okay. So the volume for a sphere is 4 by 3 pi r cube. So that's the formula. Volume is 4 by 3 pi r cube. We are going to differentiate with respect to time. So we get dV dt equals to 4 by 3 times 3 pi r square. So it becomes surface area. Do you see the volume becomes 4 pi r square, which is surface area, right? And dr dt. We need to find dr dt when time is equal to 6 minutes. Now, after 6 minutes, what is going to be the radius? We need to figure that out also, correct? That is kind of very important to understand. So since the sphere balloon with radius 10 meter leaks, so what is the volume for 10 meters? We should find that. And is losing 150 meter cube per minute. So in 6 minutes, it is going to lose 6 times 150, correct? So the volume when the radius r is 10, right? Let's write this. So will be 4 by 3 pi 10 cube. Correct? So that becomes the volume when it is 10. So which is equal to, let's use calculator. So we're going to use a decimal value here. So it is 4 times pi times 1000 divided by 3 equals to, in decimals, we'll write this volume as 4188.79, okay, meter cube. Now, find the rate of decrease in radius after 6 minutes. Now, rate is 150. So the loss is in 6 minutes. Decrease in volume is how much? Is 6 times 150, correct? So the volume after 6 minutes, volume is going to be 4188.79 minus 6 times 150. Is it okay? So that becomes the net volume at this time. So I already had that number. We'll take away 6 times 150 from it. So we get this as equals to 3288.79. Perfect. So that is the value of volume, right? Now from here we can find what is the radius, right? So because we need to plug in the radius here, so that is the volume. So the radius is, so let me use some more space here. So if we know this volume is 4 by 3 pi r cube, so the radius will be, okay, so radius, let's rearrange, okay, so radius will be equal to 3 by 4 pi times volume cube root, right? So we bring this here and take cube root. So that is what it is going to be. So it is going to be cube root of 3 times 3288.79 divided by 4 pi. Correct? So let's do this. So we have this number. We'll multiply this by 3, divide this by 4, and then again divide this by pi, and then we'll take cube root. So for this number, we are going to take cube root. So we have cube root of our answer, and that is equal to, let's write 9.22. So that becomes the value of radius, correct? So we worked out all this and found that after 6 minutes, radius will be 9.225 meters, right? Initially, it was 10 meters. You get an idea, right? That is what it is. And now we can find what dr dt is. Perfect. So dr dt will be equals to 4 pi r square will come in the denominator. So it is 1 over 4 pi r square times dv dt. Correct? So which is 1 over 4 pi, radius is 9.225 square, and dv dt is minus 150. So it is decreasing, right? That minus only indicates it is decreasing. Correct? So we'll just square this. Okay, let's do it. So we'll do 150 divided by, within bracket, 4 times pi times 9.225 square, bracket close, equals to. So we get this as equal to 0.14 minus 0.14. Correct? So the radius, change in radius is negative 0.14 meters per minute. Correct? So that is how we are going to answer this question. Now it's very kind of critical to understand that after 6 minutes we have to find radius. Right? So one step is find radius. Perfect, which you can find since you know the net volume after 6 minutes. It is decreasing at the rate of 150 meter cube per minute. So 6 times 150 decrease from the original volume will give you the volume after 6 minutes, and then calculate the radius. Okay, that is how it should be done. I hope that's straightforward. Now this negative only shows decrease, right? So it is decreasing. So let me write down the answer. It is decreasing radius at the rate of 0.14 meters per minute. Perfect. So that is how we are going to answer. Question number 8. Sand is being poured onto a conical pile at the rate of 9 meter cube per hour. Friction forces in the sand are such that the slope of the sides of the conical pile is always 2 over 3. How fast is the altitude increasing when the radius of the base of the pile is 6 meters? So the situation is kind of like this. So that's the kind of pile which is getting made, conical shape. So the ratio of this, let's say, at any time is 2 over 3. So the diagram is not really showing that kind of thing. This is 2 and this is 3. Okay, fine. So that is the ratio. And the rate at which the pile is being developed is 9 meter cube. Let me write here 9 meter cube per hour. So meter cube is volume, correct? And this is time. So we get dV dt. So that is kind of important. Units help you many times to figure out what you're working with, correct? And also we get a relation between radius and height, right? So we also get here that radius over height is 3/2, right? So this is r and this is height. That ratio is maintained, radius over height. Now, how fast is the altitude means we want what height is, right? So how fast is the altitude changing? So we'll have to write radius in terms of height, which is 3/2h. So in our formula, we'll replace radius with 3/2 height, correct? So I hope that gives you some base to work with. Now, what is the volume of a cone? Now, volume of a cone is 1/3 the volume of a cylinder, right? Pi r square h. Since we know that radius is 3/2, so we'll replace this with pi 3/2 h whole square times h. So we get volume as a function of height 1/3 pi 9/4 h cube, or cancelling we get 3/4 pi h cube, correct? So we can simplify this a bit. Okay. Now once we have this, we need to find rate of change of volume with time, correct? So say how fast is the altitude increasing when the radius of the base is 6. So when r is 6. Okay. So when r is 6, we can find what height is also. Okay. So let's differentiate with respect to time. So we get dv dt equals to 3/4 pi times 3h square, right? Which is 9 pi by 4h square times dh dt, I'm sorry, dh dt times dh, which we need to really find, okay? Now, we need to find height when radius is equal to 6 meters. So, when radius of the base is 6 meters, so when r equals to 6 meters, height will be equal to, we'll use the other way, right? So 2 over r over 3, correct? So height will be equal to 2r over 3, so which is 12/3, right? 6, which is 4. Now that is the ratio of 2:3, correct? So height is 4. So let's find the height, rate of change of height. So dv dt is given to us as, we wrote 9 meter cube. So let me replace the values, 9. And then we have 9 pi over 4. Height is 4 square. And we need to find what dh dt is, correct? So this is better. So that 9 and 9 cancels, 1 of the 4 cancel, correct? We'll bring these terms on the left side. So we get 1/4 pi equals to dh dt. So that is simpler, right? So that gives us the answer that the change in altitude is positive. It is increasing at the rate of 1/4 pi, and units are meters, and the time is in hours. Correct? So that is how you're going to solve it. So in this case, you need to relate height and radius and find both these things under the given conditions. I hope that makes sense. So what you're seeing here is a variety of questions, all kinds of shapes. And now let's get to the last. Now here is an example where we have two vehicles which are going in different direction, and we need to find when the distance between them is minimum and what is the rate at which the distance is increasing or decreasing. We'll also try to understand when is the distance increasing and when is the distance decreasing. Question number 9. At 4:30 p.m., a car traveling east at 100 kilometers per hour is 45 kilometers west of an intersection, while a truck traveling north at 60 kilometers per hour passes through the same intersection. At what rate is the distance between the two cars changing at 4:45 p.m.? Are they separating or approaching each other at this time? When is the distance minimum between the two cars? Now, so the three things which we need to find is the rate at which the distance between the two cars is changing at 4:45, that is 15 minutes after, and from that rate we have to figure out whether these vehicles are approaching or separating. And this calculation, the last one, when is the distance minimum between the two, helps us to figure out whether our answer for separating or approaching is correct or not. Correct? So I hope that makes sense. So let's begin by sketching the scenario. So let us say that this is the north direction. Correct? And in this intersection, the truck is going north and the vehicle on this side is going east from west. Now at an instance 4:30, this particular vehicle is 45 kilometers west of this intersection. So the total distance here is 45 kilometers from the initial position. Let's call this position as A. Correct? So at this time, the truck is here, right? So let's call this as B. So that is the instant. Now as the time passes, truck moves and the car also approaches. So let us say at time t, A reaches to this place and the truck reaches to the other. Let's say because they are going in that direction. So the distance between them is this, right? So we'll call this particular thing as the distance S, which separates the two. Perfect? Is that clear? Now we have to work for a particular scenario where time is after 15 minutes. So when t is equal to 15 minutes means 1/4 of an hour, correct? That is 15 minutes. So when time is 1/4 of an hour, which is 15 minutes, during this time, the car, which is moving at the rate of 100 kilometers per hour, it will cover how much distance? 1/4 of 100, right? So this distance basically covered will be equal to 100 times t, and the distance here covered will be 60 times t, since that is the speed of truck traveling north, correct? So if this is 100 times t and that is 60 times t, then the actual distance at any time will be 45 minus 100t whole square times 60t whole square to get S. So I hope you got this concept and the drawing, correct? So let's call this point here. So that is along when the truck moves. So from this you can always see that we could relate display separation. So separation S square is equal to this distance, right? So from here to here, which is 45 minus 100t whole square plus 60t whole square, correct? So that is the relation between time and the separation between the two. Is that clear? Perfect. So we can actually take derivative on both the sides. So if I take derivative, so let's differentiate this with respect to time. You get 2s ds dt equals to 2 times 45 minus 100t times the derivative of inside function, which is minus 100, plus you get 2 times 60t times 60. Perfect. You can simplify this by cancelling these 2's. Now, to find the minimum distance, let's first find the minimum time when the distance is minimum. This derivative should be 0, right? That is one thing. So we can find minimum distance. But to find the rate of change, which is part 1, or we can straight away substitute the values here. Now, at t equals to 1/4 of an hour, what is s equals to? Let's calculate this part, right? So at this time, the distance will be 45 minus 100 times. So this distance will be 100 times 1/4, which is 1/4 of 100, or you can say this distance is 25, correct? And so the balance distance will be 20. Here, 1/4 of 60 is 15, right? So this will be 15. So after, let's draw a diagram here. Let me draw a separate diagram here. So what we are saying here, that we have this distance as 20. This is at t equals to 4:45, right? So it has moved 25 kilometers. So distance left is 20, and the truck has moved 1/4 of 60, which is 15. So that will be equal to 20 square plus 15 square root. So let's calculate this, right? So we have square root of 20 square plus 15 square. That is equal to 25. So this distance is 25, correct? So we have a distance of 25 between the two. So at t, so we can say at t equals to, that is 4:45, when t is 1/4 of an hour, correct? After 15 minutes, we can substitute these values here and find ds dt, right? So let's do that part. So ds dt, and s we found is 25, so let me write 25 here, equals to 45 minus t is 1/4, which we did here, calculate, correct? So time is 1/4, so it is 25 times minus 100 plus 60 times 1/4, or let me write 1/4 here now this time, okay, times 60. Let's calculate this value, okay? Let's calculate this rate of change, okay? So the rate of change, ds dt, will be equal to, we can open this bracket and divide by 25, right? So basically this is 20, so it is minus 2000 plus 1/4 is 15, let's do 60 times 60 divided by 4 equals to 900, right? So this is 900, and then we divide this by 25, correct? Okay, so we'll do 900 minus 2000 divide by 25, so that gives you minus 44. So minus 44 is the rate of change after 15 minutes at 4:45, correct? And the units will be kilometers per hour. Now what does this negative means? Negative means that the distance is decreasing between the two, right? So we can write here, it is decreasing at the rate of 44 kilometers per hour at 4:45. Okay, so that is what we came up with. Now to verify whether it is really decreasing or not, let's do the last part, which is when is the distance minimum between the two, right? Now how do you work for minimum distance? So for minimum, the rate of change should be 0 for minimum distance, right? So for minimum, ds dt should be equal to 0, correct? That is what will give you a critical number, right? So let's get back to our equation, which was which is right here, right, which is here. So let's get back to this equation and equate this to 0 to find the minimum. Is that okay? So what we will do now here is that we'll say ds dt equals to 0. That means 45 minus 100t times minus 100 plus, let me write this as 3600t should be equal to 0. Correct? That is what it means. So from here we can find time when the distance is minimum between the two. You get the idea, right? So let's find the time when the distance is minimum between the two. So when you multiply this, we get, let's space here. Okay, so let's open this. So that gives you minus 4500 plus 100 times 100t plus 3600t equals to 0. So let's solve this time. So from here, when you add them, you get, you can write this as 4500 equals to 13600t. So t is equal to 4500 over 13600. So let's calculate this answer. So 4500 divided by 13600. So that gives you, in decimals, let's say, 0.33 hours, correct? So when time is 0.33 hours, that was 0.25. So after some time, right, it is going to be at the minimum distance, correct? So in minutes, you could multiply this by 60 to get minutes, which is equal to around 20 minutes, right? 19.8 minutes. So which is 19.8 minutes, right? So that is what we get, 1/3 of a minute, which is approximately 20 minutes, you can say. So the minimum distance will be around 450, right? So we can say add 4. If I add 19.8 minutes, right? So we can just add 20, around 4:50 p.m. we expect minimum distance. Between the two, correct? So that also verifies that after 15 minutes, the distance is decreasing, right? So distance is actually decreasing, and after 450, it will start increasing. It will have a minimum distance at 450. Does it make sense to you, right? So that is how you can solve this particular question. I hope you find it interesting and useful. Feel free to write your comments and share your views. Thanks for watching and all the best.